All right, here we go. Now we're going to give it a shot. All right, so first off, we're taking a look at a little bit of a review from this chapter. So talking about properties of a rhombus, I gave you the length of the diagonals of 12 and 18. Remember, because of that blown over effect, there's a longer and a shorter diagonal. So this diagonal that we draw in right here, there's your longer diagonal. And then this diagonal is your shorter diagonal. What happens? What do we know about the diagonals of a rhombus? There should be two things that you know in order to solve this problem that you need. They bisect each other. So that longer diagonal, instead of it being 18, I'm going to put it in here as 9 and 9 rather than 18. And then same thing, shorter diagonal, I'm going to put in here as 6 and 6 rather than a whole length of 12. Okay? Second thing, there's one other thing you need to know in order to work through some stuff. Everybody got it? They are perpendicular as well. So what I know is that I've got 4 right triangles in this picture. Okay? Notice the question, however. The question says find the area of rhombus ABCD. Well, we don't technically have a formula for the rhombus. Therefore, instead, we can go through and we can find the area of each one of these triangles. So all 4 of these triangles are the same type of triangles. And therefore, if I can find the area of one, all I got to do is multiply by 4, and I have the whole area. Okay? So in this case, remember area of a triangle, base times height? Well, the base and the height are the 6 and the 9. Okay? They happen to be, remember they're always perpendicular to each other. So 6 and 9 are your base and your height. We multiply that, we get 54. Divided by 2 because it's a triangle. That means the area of each one of these triangles is 27. And we've got 4 congruent right triangles in this case. So we multiply by 4, and therefore our area in this case is, or should be, 108 square feet is what you should come up with. 108. Okay, 108 square feet is what you should end up with. Quick question for you, I didn't ask you on this, but just on a quick side note. What would you have had to do if I asked you to also find the perimeter of this shape? What is it? Yeah, in this case, another place where the right triangle comes into play, you would have had to do Pythagorean theorem to find a side length, and then you could have multiplied that side length by 4 to get the perimeter. Okay? Again, I didn't ask you to do that, but just a heads up if I would have, that's where you're headed. Really, the key part to this is the fact that you've got bisecting diagonals and a right triangle. Okay? Everything works off of those 2 properties. Anybody have any questions? Anything that did not make sense from this? Okay, and let's keep going. So next problem. Here's one of our factoring problems. We met yesterday as a geometry group of teachers. I will tell you, you'll see another factoring problem on the next test. Okay, we just started putting together the next test yesterday, and we decided we're going to add another factoring problem on there. So just as a heads up, that'll be coming up. So if we factor, let's work through our process here. Put down the 2 sets of factors. And then remember, same 3 steps. We always start with factors of our first term. So in this case, what multiplies to give you 2x squared? You got 2x and x. And then we move to the other end, our constant term, factors of 20. Okay? In this case, we've got 1 and 20. 2 and 10, 4 and 5, we've got quite a few options. So I'm going to start with the 4 and the 5, and we'll see if that works. Okay? Remember, step 3 then, anytime you've got a number in front of that x squared, you got to check the inside and the outside to see if you can get our middle term. Okay? We're looking to see if we can get a negative 3x from that. And so when we go through and we check, the inside gives me 4x. Outside gives me 10x. Oops. From 10x and 4x, any way I can get a negative 3x out of that? Nope. No way I can get, by adding or subtracting, there's no way I can get that. So therefore, we know that we don't have it quite right yet. So let me get rid of this. And instead of 4 and 5, let's flip it and let's try 5 and 4. And see, and go again and see if it works out. Inside gives you 5x when you multiply. Outside gives you 8x. Any way from that I can get negative 3x? That one I can, right? As long as the 8 is negative and the 5 is positive. Which means the negative 8 comes from the fact that That is where the minus sign needs to go, and that's where the plus sign needs to go. So again, if I once again relate this back to, oops, let me get rid of this stuff. If I once again relate this back to the test, if you get this far on the test, if you've got it factored, this would probably be like a 3-point problem on the test. That'd probably be 2 out of the 3 points you've done the factor. That's probably the hardest part. Don't forget though, right here, solve. You got to solve this problem. We've factored it. We have not yet solved. This is, remember, where the zero product property comes into play. Okay. So if we take a look, now we go through and set each factor equal to 0, and I actually solve and get my 2 answers. Oops. Yeah. And now we solve. Subtract the 5 over. I get 2x equal to negative 5. Divide by 2, and therefore x equals negative 5 halves, negative 2.5. And then on the other side, all we have to do is just add the 4, and therefore x equals 4. And there are your 2 answers for that type of problem. Again, being completely honest, you will see another factoring problem, like I said, coming up on the test. Okay. Any questions on this one? Anything not make sense as we were going over it? Okay, last one then. And again, you will still see some trigonometry type of stuff. It's one of the main ideas of this whole class. It's probably the most important thing you learn in this class is all the trigonometry stuff that we've done. And so if we take a look at problem 3 here, from the top of a 108-foot lighthouse, okay, so let's go through and put that in here. This is 108 feet. The angle of depression of a boat at sea is 27 degrees. You can see that that's in the picture. We want to find the horizontal distance from the boat to the base of the lighthouse. So what we're actually looking at is we're trying to find that distance right there. That's what we're looking for. That's where I'm going to put x. We've already got this piece as 108. Now, how does that 27 degrees help me in this problem? It's not even in the triangle. Anybody tell me? How does that 27 degrees help me? There's a couple of options couple ways we could use it. What do we think? Connor, what do you think?
Because we hopefully flip it around, it'll be like the angle on the bottom.
Okay. Yeah. If you go back, so this dotted line at the top, and then the bottom down here. Let me move this down so I can actually reach it. These 2 lines are parallel. This is taking a look at the lighthouse straight out. This is straight out from the base. Therefore, these are alternate interior angles. Kind of like Conrad was saying, if we just kind of flip that around, if we just rotate that triangle, that means this angle is also 27 degrees. Those are alternate interior angles in that case. And now, this basically becomes, if I highlight the rest of the triangle, that red triangle right there basically becomes a right triangle trigonometry problem. Okay? So quick question on this one. Is this a sine, cosine, or tangent problem? Based on what you see. Sine, cosine, or tangent? Okay, now. Come on in, have a seat wherever there's an open spot. What do you think? Peyton, what do you got?
It is a tangent problem because it is like the leg.
Yep, very good. It is a tangent problem because you're dealing with the 2 legs. The opposite leg and the adjacent leg to the 27. So if we set this up, that means we have the tangent of 27 over 1. Tangent of 27 over 1 equal to opposite leg over adjacent leg. So the leg that's opposite is the 108. The leg that's adjacent is the x. And now we're right back to, again, we've solved proportion after proportion after proportion. Cross multiply, we get x times the tangent of 27 equal to 108 when we multiply the other diagonal. And now to get x by itself, we got to divide out the tangent of 27. And therefore, that takes us to, somebody help me out on this one. I don't know what the answer is. It says to the nearest foot. What is the answer on this one? What do you get when you do 108 divided by tangent of 27?
I got 211.96 feet.
211.96, yes? Okay, I see some. So 211.96 is what you get. And if we rounded to the nearest foot, we would then go 212 would be our final answer. Well, there's where we're at. Okay. So this warm-up is a lot of stuff that you're going to kind of see on your next test. Some of the geometric connection stuff, some of the algebraic connection stuff. So that's kind of why we wanted to put that together. Okay? Does anybody have any questions on any of that? All right. Today then, the lesson that we're going to get into today, we're going to take a look at we're going to do a little exploration at your table here. I got a couple of things that I want you to grab. What I'm going to have you do is, you will need, for each person is going to need 2 sheets of patty paper. Okay? You need 2 sheets of patty paper, and then I've got an activity that I'm going to have you work through as well. So if you would, what I would like you to do is, here, I'm gonna have the person in the closest part here to me. Grab 2 sheets of patty paper for everybody in your row, and 1 sheet of paper. Okay? 1 sheet of paper and 2 sheets of patty paper for everyone in your row. Come on up. One worksheet and 2 sheets of patty paper for each person. All right, here we go. Little exploration. So if you take a look, step number 1. On one of your sheets of patty paper, go ahead and draw any type of triangle. Does not matter. Okay? And I would make it fairly large. Make it so that make it a fairly large triangle, so you've got a little bit of room to work.
Like any type of triangle?
Any type of triangle, yep. Can be obtuse, can be a right triangle, could be equilateral, could be any type of triangle, just make it fairly large. Alright, then, once you have that, notice now it says they want you to pinch the patty paper to locate the midpoint. So what you're going to do is take the 2 endpoints of one side, put them together, kind of basically fold them together, and then fold it in the middle. So that's, you're trying to find the midpoint of each side. Okay? Trying to find the midpoint of each side. And I'll kind of come around and check on you, see if that makes sense or not. Make sense? So these 2 points, these 2, you would go through and match it up. You're going to do it for each side. Okay? Alright, so now you get to help this table. You get to figure it out. So what you're doing is, yeah, so like this would be, so if you match these 2 ends up, put them together, and then you find them. So you do this on each one of these sides. Okay? At least you got it. Yeah, what I would do is got it. Good. How we doing? You know what you're doing?
Or you need to go down the side.
I think it's even the line.
So here's the idea, we're taking these 2 midpoints, you're gonna match them.
Well, I can't do that. I'm just bring that triangle.
You're gonna match them up and then put a crease. And where that crease is the middle of that side. Then you're gonna do the same thing for the next side and the same thing for the next side. Yeah, so they're matched up. So here you match up these 2 sides, right? So that means that point right there is the middle of that side. Then you're gonna do the same thing with this side, those 2 points, the midpoint. Yeah. Yeah. What are we doing? You guys got it figured out? I think so. So if you're trying to find the midpoint of this side, you can take the side, and we're gonna hold this, we'll and then do the same. That's all. Got it? Find the midpoint? Make sure you get it okay. We move back here. You're good. So you're gonna be trying to find the midpoint of the side. So you take those 2 midpoints, we'll match them up. And then wherever
You're supposed to hold all of one side. No, it says full point.
you do it inside.
It says full
Midpoint of this side. You take those 2 midpoints on the side. Sides up there. And that hole now is the back. And the next side is in the midpoint side. Match those up.
Alright, so what you should have is something that kind of looks like the very beginning here. Okay, if you take a look, you should have ended up with the midpoint of each one of the sides of the triangle. And what I want you to do then is actually draw in the line, connect the midpoints. So you should your triangle should end up looking something like that at least. Okay? So connect the midpoints. Connect the midpoints. Once you found where all the midpoints are located, draw in a line connecting them.
Oh, that's how you do it. You draw lines.
Again, help each other out. That's why now that we're all back on top of each other, basically, might as well help each other out since you're sitting right next to each other. Yeah, I saw you. I saw the look you gave me when I said that. Yeah, I read the look.
So when you want to do this, so when you rather than draw that line, this is one midpoint, right?
Oh,
This is the other one. And this one is the other one, right? Remember? You want to these 3. So you're kind of drawing a couple.
Alright, so if we take a look, you should have 4, your big triangle that you started with now should be kind of divided into 4 triangles. And the idea, I told you what we're looking at today is what's called a mid-segment. What you just drew in are mid-segments, okay? Okay? They are segments that connect midpoints. So for example, if you look at the picture that's up here, this segment right here, that's the segment that connects this midpoint to that midpoint. That is one of your mid-segments of this triangle. And you drew in all three of them. There are three different mid-segments. Okay? What we're going to take a look at is what are the properties of those mid-segments. So now we completed step number 1. Let's go to step 2. So now here's where the second sheet of patty paper comes in. Take a look. Place a second piece of patty paper over the first one and copy one of the 4 triangles. Copy only one of the 4 smaller triangles that were created. And so once you've copied that, then we move on to step 3. I want you to take a second to compare the 4 triangles by sliding or translating the one you just copied and take a look at the other triangles. Just kind of slide that one around and see how does the one triangle compare to the other 3. And then fill in the box with what you think is true. The 3 mid-segments of a triangle.
I feel like that's
How is it? You good? Yep, you're good.
Is yours?
So what I think you probably found pretty quickly was what's true about those 4 triangles. They are all congruent to each other. So our first property, our first conjecture, if you will, the 3 mid-segments of a triangle divided into 4 congruent triangles. We've got 4 congruent triangles. All right. So then, to lead into the next part. Step 4, notice they tell you they want you to mark all the congruent angles in the drawing. And what conclusion can you make about the mid-segment? So the drawing that they're talking about, if I go back up to the top, is your original, let me go here, your original drawing. They want you to go back, so when you have all your triangles here, mark the congruent angles and mark the congruent side lengths. Okay? Put all the congruent markings in on your original sheet of patty paper, the first sheet. Which angles are congruent? Which sides are congruent? Put those markings in. Mark the congruent angles in the 4 triangles. Which angles are the congruent ones? Which sides are the congruent ones?
Oh, I turned it over.
Alright, so now take a look kind of back up here. So there's some random triangle that I put together. I approximated the mid-segments that I put in, okay? Knowing, and I guess I should put in a few more markings here. Knowing if this is the midpoint of this side, I know that this side is congruent to that one. If this is the midpoint of this side, I know these two parts are congruent. And if the bottom one is the midpoint, then I know that these two pieces have to be congruent to each other as well. Okay? So we know that part of it. Notice that I marked one of these angles. Okay? This angle right here. What I'm going to compare is the top triangle to this bottom left triangle. What angle is congruent to that one in the bottom left triangle? Where would I put the same marking? What is it? The bottom left. This is basically just a translation is all this is. This triangle slides right into place over here. It would also slide right into place over here. Okay? So therefore, that means these two angles are congruent to each other. And I'm going to start right there. What does that mean? What does that tell you then about the mid-segment? How does this mid-segment right here compare to this side length? Based on those angles that we just know, we know right now. What has to be true about those two things that I marked in blue?
Parallel.
How do you know? You're right. How do you know they're parallel? Yeah, those two angles are corresponding angles right there. And if corresponding angles are congruent, they're only congruent when the lines are parallel to each other. Okay? They're only congruent when the lines are parallel to each other. And so, property number one then, down at the bottom of your sheet, I'll go back so you can kind of see so it matches up. So down here, there's actually two parts. So in line number A, or part A here, the mid-segment of a triangle is, let me add this back in, parallel to the, I'm going to call it the third side of the triangle. The mid-segment is parallel to the third side of the triangle. Chase, you with me? Uh-huh. Write it down. Quit playing games. Not anymore, you're not. A mid-segment of a triangle is always parallel to the third side. So what I mean by that, if I go back to my picture for a second. So the one that I put in blue here, this mid-segment is parallel to this side. I'm not going to mark this up too much, but this mid-segment would be parallel to this side. This mid-segment would be parallel to that side. Okay? So your three mid-segments, they're parallel to the side that's not connecting the midpoints on. Okay? So that's what I mean when I say the third side. That's the idea. All right, there is another property that we have to add in as well. And that is, not only are those two lines parallel, let's compare the lengths. How does the length of the mid-segment compare to the length of the third side? What do you think? Let's get rid of some stuff here. What's that?
It's half the length,
How do you know it's half?
because they're the same, they're congruent.
Hang on one second. Let me put this back here. If we were going to put some markings in here, okay? For example, if I was going to put some markings back with the triangles again. Let me add those back in. Notice at the very top triangle here, we've already got 1 and 2 markings. So that means the third side must be the 3 markings. Okay? For this one, we've already got 1 and 3. That means this piece must be the 2. And then this one must be the 1. Here's what I want you to take a look at, and what Cody was getting at. 3 markings here. That has 3 markings. And that has 3 markings. Therefore, this length right here is half of that total base. Okay, you need 2 of those in order to create the entire length, which is our last property that we're going to then take a look at. So if you go back to your sheet, to the very bottom part, part B, not only is a mid-segment parallel to the third side, it is also half the length of the third side. It's not only parallel to the third side, it is also half the length of that third side. Again, based on the congruent triangles and all that kind of stuff that we're talking about. All right, so let me give you just a couple of examples of where this stuff, we've been using properties of quadrilaterals to kind of solve problems. Let me at least give you a couple of examples of where you would use mid-segment properties and how they can be used to solve a problem. So if we go through and we take a look, oh, I did put in the math notes kind of a basic summary of what we just talked about. A mid-segment connects midpoints from any two sides of a triangle. That's the definition of a mid-segment, and we already talked about being parallel and half the length and all that stuff. But here's a couple of examples. First question, this one right here. Is this a mid-segment in the triangle? Just based on what you see. What do you think? Why? How can you tell it's a mid-segment without me telling you? How can you tell that it's a mid-segment? What reason? Cody? Yeah. If those two parts are congruent to each other, that means this point is the midpoint of that side. If those two markings are congruent, that means this point is the midpoint of that side. And therefore, this is the segment that connects two midpoints. Let me ask you a question. What's the measure for angle X? 40 degrees. Goes back to that idea again. We know that this has to then be parallel, so those are corresponding angles. There's how we can very quickly solve. In this case, we know that that has to be 40 degrees. How about the one next to it? Again, same reasoning behind having a mid-segment. What's the length of X?
24.
Yeah, we just said one of the properties is, if you have a mid-segment, it's always half the length of the third side. So you know that this must be 24. Okay? How about here? How about the next one here? What's the value of X on that one? Yeah, we go the opposite way. If you know the length of the mid-segment, well then that's got to be double the length. So in this case, X equals 60. And finally, our last one, if we take a look at this one, let's start with angle X. Let's start there. Any ideas? Blow this up a little bit so you can see it a little better. How can I go about finding angle X? What do you think? What's your process? This one's not as straightforward. And this is the one that we're going to kind of end on today. What do you think? Any ideas? Cody, what do you got?
65.
Where's 65 coming from?
So because the triangle at the right side.
Yep.
No, that's a right triangle, so it's 90 degrees. So
Yep.
you have two of the angles. So you can subtract the angle by 90.
Okay. Yep.
Like
So-
on the other side.
So if we start over here, I can find that missing angle just doing the triangle sum. We know that three angles have to add up to 180. And so if we go through and we do that, we know that this angle must be a 65-degree angle. And then to finish it off, just like we've done previously, those are corresponding angles. So therefore, X must be 65 degrees. Okay? Real quickly before you pack up, what about the mid-segment? Hang on. Stop packing up. Give me a minute.
I can't keep you on.
All right, I'm going to take a minute then.
27.
What do we do? What is it?
I got Y equals 27.
What did you do?
I did math.
Good. That's good. If you take a look at this one, stop for a second. Give me a second. God. Oh, see, I screwed up my screen. Let me go back. Hang on. There we go. All right. If you take a look, we know that that mid-segment is half the length of that. Therefore, we know y minus 2 has to equal 25. And there, from there, we do math, and we get y equals to 27. There's our answer. Your assignment for today, coming out of today, is to finish, if you did not start it before, the 726 Practice to Learn worksheet. Okay? 726 worksheets. Have a good day. Welcome back, everybody. left.
Today's gonna be a good day.
What total chaos. It's a weird feeling. Come on in, make sure you sanitize and sit where you want to sit. But sanitize it first, please.
Straight to the back.
Yes. Thank you too.